Alright, good day guys. How are you all doing? So we're talking about ordinary differential equation under the variable separation. And when you talk about variable separation, it's actually something very easy. It's just a process where you have a certain function x defined as an independent and also function y being independent. And this is a first order differential equation. In that point, I usually urge you guys that this thing, don't let it confuse you. Make sure whenever I use something like this under ODE, my year out there, okay, just try to make sure you change it to something like this, dy dx. There is a reason why. This is correct, this is also correct, but make sure it is in this form. There is a reason why. You will thank me later. Now, from that point now, what we just need to do is that we want the function of y in this side and we want the function of x in the other side. Everything that requires x. And also you can just say either x here, y here, any of the two you want to do, they're the same thing. Now, and how do you do that now? You can easily say that what? Divide the y the y is equals to multiplying cross multiply. You have function x times function y dx. Then you divide what both sides with what function of y. So therefore we have function of y then this. So you have dy over function of y equals to function of x dx. So you can see that they are both in their separate what parts now. So in that point, then you can now integrate both sides. So you integrate the y with respect to the function of y, integrating what the function of x, what the x. Are you get what I'm saying? So let's look at some certain examples and how we can actually move on with some certain questions like this. Thank you. All right. So there are some certain things I want to explain to some people also. When it comes to variable separation, they usually have some certain problem. And what's that problem is constancy. People feel like, how is this constancy taking C1? How is it taking C2? Or at times you have K1, or at times you use it A, you have B, you have different sort of things under the constant. Now let me tell you, you see all this nonsense, they still conform to ordinary C. It is if you like, you can actually utilize some of this. Are you get what I'm saying? And the moment you start, let me just put that under first order. Let me just put it that way. As at now, whatever you are doing could actually conform to only C, which is just single constant. Now, what I want to tell you guys is that at times, why they usually use all this is that whenever you are dealing with the factor them, you can have your answer, you can have your constant already, whereby a constant will still multiply your arbitrary constant. Something like this, 4C. So in this point now, it is a constant, it's an arbitrary constant, it will still lead to a constant. But the moment you use C, you won't be able to use C again. That is why at times they just say, let this even be C1. So even though your answer later gives you only C1, that's even though there's nothing attached to it, you can still easily change it back by saying constant 1 is still same thing as what? As ordinary C. You get what I'm saying? So even though you have something like e raised to power C or any sort of things, multiplying a constant, not a variable, a normal exponential raising to a constant, this will still lead to a normal what? Constant. People do get confused in all these things. If you have what do they call it? Now at times they usually change it by saying maybe this, all this now, there's a way we are breaking it down. I'll explain. Can be what? Can be utilized as another constant A, so as not to use C repeatedly. You get what I'm saying? So don't that is it. There's nothing big about you having C1, C2, then later on you have C. Like how does this happen? Now the second thing I want to explain is at times if you have something like this, let's say you have in y plus let's say in x. Okay, let's say in y is equals to in x plus c. Now you have actually done your breaking down and everything, then your answer lies in this point here. You know we have to divide further, right? Now in this point now, if there is in present in all variable except from the constant, you can use a shortcut then so as to quickly move on to your answer by applying in to constant that you have, because in times constant will still result to what? Constant, an arbitrary constant. You get? So in that point now, the logic will be much more easier. Instantly when you transfer this to here, you have in y over x equals to in c. So in that point, you can quickly cancel in, then you have y over x equals to what? C. You get? So you even move, start breaking down step by step. Those will waste time. You get what I'm saying? So there are still the steps you are still going to follow just to make things clear. Now, if you look at this certain question now, we have 1 plus x dy minus y dx equals to 0. So we know the first thing we need to do is what? We shift them to each side. So in that point now, why shifting them? We need y variable here, we need x variable here. So we can say you have 1 plus x the y equals to y dx. So at that point, what do you think we can divide? We need to clear off x here, so we can divide this by 1 plus x. And we need to clear off y here, so that means you can add y to this. Then also you have 1 plus x, then y. So at this point, this cancels out, and at this point, this what? Oh, sorry, this what? This cancels out. Are you get what I'm saying? So we are going to be left with the y over y equals to x over 1 plus x. So what is our next step is that what? We integrate the function. Then integrating this and integrating this. We all know under the law of what? Under the law of integral, that whenever you integrate a certain function du over u, it will give you what? In u plus what? A constant variable. Literally, we want our constant to be basically on the function of x. You get? Because we want to derive y as an equation. So at this point now, integrating the y over y would give us what? In y. Y in y. So integrating x over 1 plus x, integrating dx over 1 plus x rather. So from this point now, you should know that we can do some little breakdown. If u is equals to 1 plus x, you have du over the x being equals to what? 1. So therefore dx is equals to what? Du, right? So from that aspect now, we can say that this is also written as what? Integrating du over u, whereby in y is also equals to what? In u plus c. Are you get what I'm saying? Hope you can see the c. So from there now, we know what is our u. What was our u? 1 plus x. So we can have in y being equals to in 1 plus x plus c. This can be a single general solution, but we are not done yet. You can put it in the terms of y. So when being asked to put it in terms of y, you have to break things down very, very well. So at this point now if you look at what I told you guys at that time, in this point we can directly put, I will show you guys the two method so as to see what I'm trying to explain. Now in this point now, since I have in here, I have in here, I can directly put into my constant also by saying in y is equals to in into brackets 1 plus x plus in c, because this is a constant. So in the moment I throw this into here, I have in y minus in 1 plus x equals to in c. And do not forget this in is the natural log, exponential log. So the log base e to the base e is also written as what? As in. So in that moment now, we know that what? You can apply logarithm law to it by saying if you have a particular log base a minus log base b, since the log are the same thing, you have what? Log to the base. If it's subtraction, you divide the function. So you have this now from this point. Moving on from this point, you are going to be having in y over 1 plus x equals to in c. So can you see what I'm saying now? From this point, it's actually easy. So therefore, you have c this in cancelled in. Then you have y over 1 plus x equals to c. So therefore, your equation will be equals to y equals to what? 1 plus xc. And that is your answer to your equation. Now, if it was that from this point, let's come back to this point. From this point now, that's in y equals to in u plus c. I decided that, okay, that might be a little bit complicated. You want to do it directly. Now, we know that we are looking for y. We have to find the limits to get our y, literally. So in this point now, you can have in, just like the same thing I did here, bringing this one back, you have in y over, what was our u? 1 plus x equals to c, right? And we need to find a way to clear our in. Don't forget that natural log to the base e. So e raised to power natural log to the base e, they would cancel out. That is, you saying e to the in, they would cancel out. So at that point, we can raise both of them by putting an exponential raised to power the function. So if we have e raised to power in y over 1 plus x also equals to e raised to power c. This cancel out this. So you drop your equation down as what? 1 plus x equals to. Now if you look at, I tell you guys that this e raised to power c is just like you having another constant again. We can just easily call it a. Hope you get what I'm saying. So either I put a or I put c, nothing spoiled. I'm still at the right part. So another time again, I can still feel like, okay, let's clear things off. You know, I said in y over 1 plus x is equals to c. I can say let's assume a is equals to Let us assume a is equals to y over 1 plus x. That means I'm having in a equals to c. Abi, hope you can see. Then from this point now, I have e raised to power c. Then I can say that this will be e raised to power what? In a. Hope you get my logic. So from there again, what will still happen? This one will also cancel up. So you have y equals to what? 1 plus x, then what? A. These two are the same thing. This is an arbitrary constant. This is also an arbitrary constant. So hope you get. So don't get confused whenever it's something like this. You can apply your normal method, or you just still utilize your C for everything you are doing. Alright guys, let's check out the example 2. So from this point under our first order, still under separation of variable, we know we have to just separate them, y here, x there. So what do? You have a raised. Why don't you start telling you this with pass through this level, right? Cos x, then the y equals to e raised to power y sin x, then dx, putting sin dx there. Then what do? We divide this by e raised to power y cos x over e raised to power y cos x. This cancels out this, right? And this cancels out this. So you are left with e raised to power 2y minus y, the y over e raised to power y equals to sin x ds, sin 2x dx. So you have sin 2x dx over cos x. So what do? Next thing, we integrate both parts, both sides rather. Then from this point, we know this can be the same thing as 1 over e raised to power y of e raised to power 2y minus y. Then your the y equals to, now do not forget, this is under double angle. Under your trigonometry, we call it double angles. Your sin 2x is equals to 2 sin s cos x. Okay, so we can change that to this, and you can have integrating 2 sin s cos x over cos x dx. So moving on to this, you have this as integrating e raised to power negative y of e raised to power 2y minus y, then the y, right? So equals to integrating, so this cancels out this. You have 2 sin x dx. So moving on from here, you have this to be integrating e raised to power negative y times this. You have what? E raised to power y, law of indices, minus y e raised to power negative y. Then you have the y equals to, the constant moves to the front. You should have known this law of logarithm before moving to something like this, sin s dx. So at this point, while moving on from this point, we can differentiate this separately. That is, we can either integrate it separately rather. So that is integrating e raised to power y minus integrating y e raised to power negative y. So you have the y equals to, then integrating sin x ds, that will give us what? 2 times negative cos x, then plus the c, our constant. So I feel like I've explained some certain things under the constant for you guys that you guys need to know. Then from here, integrating e raised to power y dy, you should know exponential law, that will be e raised to power y. Then this point here, we need to apply what we call IBP, that's integration by parts, because we have two functions here. So at that point, I can say my du is equals to e raised to power negative y, because we've done this certain time. Then my v is equals to y. So when I integrate this, I have u being equals to, if I'm to integrate e raised to power negative y, the y, I could say let m be equals to negative y. So my dm over the y will be equals to negative 1. That means that my dm will be equals to negative the y. Are you with me? The same thing, my dy will also be equals to negative dm, right? So in that point now, I'm going to be having integrating e raised to power negative, e raised to power what? M, what's my dy? Negative dm. Then I have negative, then dm. So automatically, my u will be equals to negative e raised to power m. Are you get what I'm saying now? So automatically, whenever you have integrating e raised to power an inverse of a certain function, it's just the negative of the function, negative e raised to power the power of the function back. But make sure you break it down with this step like we just did. So this is our u. That's u. Then the v over the y would be equals to 1. So that means the v is equals to the y. We need this idiot. So from the aspect of view, we have integrating this. Now integrating the whole part of this. Do not forget now will be equals to uv. What's our u? What's our u? This is will be equals to uv rather. This is our u and this is our v. So you're having and don't forget this u will be equals to negative e. What was our m? Negative y. So you're going to be having minus into brackets negative e raised by negative y times y. You have negative y e raised by negative y. That's our uv. Then minus integrating. Please do not forget, put that back in your mind. Minus integrating u the v. So u then the v. So you've got negative e raised by negative y u the v then times the y. So equals to so that's equals to your negative 2 cos x plus c. So at this point you have e raised by y, then plus y e raised by negative y. Then you should know this to become plus. So you should know integrating e raised by negative y directly, you are going to be having what? Let's still put it there like that. Let's put this on plus integrating e raised by negative y, the y equals to so that is equals to negative 2 cos x plus c. So from here you have e raised by y plus y e raised by negative y. This becomes minus e raised by negative y equals to negative 2 cos x plus c. You should know why this is equals to this. I've just done it not quite long. So from that aspect of view now, this is our answer to our general solution of the equation already. But you can start to break it down much more. By doing that, I can say I have y e raised by negative y equals to negative 2 cos x plus c, then minus e raised by y minus plus e raised by negative y. So if I'm to make this side looks only me needing I need y, at this point I could say divide both sides by e raised by negative y, then e raised by negative y. So I have this. My y would be equals to negative 2 cos x over e raised by y. So this will still give me plus the constant c over e raised by negative y. Then from here I should know you have negative e raised by y over e raised by negative y, right? Then plus e raised by negative y over e raised by negative y. So at this point my y will be equals to negative. So this automatically you should know negative e raised by negative y just like you say 1 over e raised by y. So 1 over e raised by y times you having negative 2 cos x. So that is just like you having this divided by 1 over e raised by y. So automatically it will become times, so it will multiply negative 2 cos x. So you have negative 2 e raised by y cos x plus e raised by y with c, then minus this is law of indices, e raised by y, then minus y. You have negative e raised by 2y, then plus 1. So this is the answers to